give.
Okay.
I
Hello,
should give.
everyone.
Oh, okay, go on.
Right. Hello, everyone, and welcome to the 2025 PIBBSS Symposium. Our speaker, Abhimanyu, will be talking about recursive information markets.
Yeah, I should give two kind of motivations for why information markets are interesting, and for the specific kind of algorithm that I'm introducing to make information markets work. The first is I want you to consider all of the different mechanisms that we have set up in the world for people to gather information. So everything from academia, if for like finding out new truths about the world, to recommender systems for, I don't know, knowing what like the current news is, or of news media for that matter, or customer reviews on products for knowing information about some product. Regulatory inspections serve the same purpose. Something you might something you might realize about all of these different mechanisms that have been developed is that by and far people don't like them, with the notable exceptions of search engines and AI assistants. The only kind of mechanisms for gathering information that seem to work are those which are based on machine learning, like search engines and AI assistants, or those based on markets, like prediction markets. And like in general, the very existence of all of these mechanisms is kind of embarrassing. If you want, like, the basic organizing principle of society in every other domain is, if you want something, the right way to get it is to buy it. So why can't we have a market for information? um I've thought about it, and like here are a couple of the reasons why markets for information are hard. The first problem is that by the very fact that you are purchasing some information, you are asserting a priori that you are less informed than the seller is. So, for example, if I am, an information asymmetry is something that matters even apart from the specific case of like information markets. Like, even real markets have information asymmetry, and if you're familiar with basic welfare economics, you will know that there's a theorem called the first fundamental theorem of welfare economics, which essentially asserts that markets are perfect and efficient as long as there is no information asymmetry. Because the problem with information asymmetry is that if the seller knows more about a certain product than the buyer does, then that means that there are going to be certain things that the buyer cares about in the product, but which the seller does not have an incentive to optimize on. And as a result, you there's kind of a race to the bottom on all of these unseen uh, qualities of the product, where like, if you want to search about this concept, the keyword is a market of lemons. um and kind of like the market just degenerates on everything that isn't visible to the buyer. And this is especially exacerbated in the case of information markets themselves, because like the thing you are buying itself is information, which means you do not have that information and the seller does. So the very product you're buying is itself an information asymmetry. And like one way you might think of solving it is, well, okay, why can't the user look at the information, decide whether to buy it, and then, like, based on his analysis of the information, make a purchase. And the problem is that the moment you look at a piece of information, you have already absorbed it and no longer have the incentive to purchase it. And so the seller has no incentive to let you look at the information in the first place. This is called the buyer's inspection paradox. um, and this is kind of what we will, like, my algorithm seeks to address. There are still other problems with information markets. The low cost of duplication, like the most obvious place this shows up in is in when it comes to actual plagiarism and like the difficulty of enforcing IP rights. Like if you sell some information to someone, how do you know that they don't just duplicate it and redistribute it for free, right? Like usually in markets where you have a high upfront cost and then low cost of duplication, differential pricing is what makes the market more efficient. But the fact that other people can also duplicate it once you have produced it, it's not just that you can mass produce it after you've produced it, means that like how can you even decide a differential, like how can you even decide the pricing of your product when other people could just redistribute it for free. The other issue is transaction costs for tenders, which means, so for example, a lot of information markets basically would look like something like you post a question, a bunch of people come up with proposals for the answer. And now, if you expect them to all produce the entire information on demand, then that is, of course, a huge cost for them. There's no, I mean, you're only probably going to buy one of the pieces of information being offered to you. And on the other hand, if you just ask for a proposal and then you let them produce the full information, there's still a huge transaction cost, and also there's a risk of you being swindled by the seller. You have no reason to expect that the resulting information would be good, barring things like reputation and so on. And this is kind of why the economy at large, like when it comes to when it comes to jobs that require providing information or some type of information, doesn't run uh, purely on a market-based system. You have firms hiring people and so on because it's to reduce that transaction cost. And finally, the fifth thing is that it's not like transferring information from one person to another person isn't free. Doing so itself is what we call learning, and that is a transaction cost. And of course, like as in every market, making any transaction cost makes the market less efficient. The hope, though, is that like I am only aiming to solve the first two problems, and the hope is that maybe the remaining, like maybe there are enough context or enough domains of information where the other problems don't matter as much. So, like for example, if we focus on information markets where the sellers are kind of providing from a preset range of like a preset corpus of information, like say from all the information on the web or something like that, then there's not much effort involved in actually producing tenders and so on, and so there would be no transaction cost of tenders. If you're dealing with markets where that transfer of information is fairly cheap, like in the sense that not particularly complex information, not like entirely new science or something, maybe the transaction cost of learning is sufficiently small, and perhaps just some social norms about not plagiarizing can, or like existing IP law can kind of address the low cost of duplication. The hope is that this might still work. So here is a solution to the bias inspection paradox. um, Amnestics. What this means is, so I mean, the problem is the moment you've looked at the information, you have absorbed it, right? So what if you just forget it? What if you take an amnestic while looking at the information that makes you forget everything that you look at while under the influence of the amnestic? That is maybe impractical or maybe hard to rely on. So here's another solution that emulates what amnestics can achieve with LLMs. So instead of you yourself looking at that information, You can subcontract an LLM to look at that information on your behalf and then forget it if it decides not to purchase it. And if it decides to purchase it, it purchases it and shows you that information. This was the idea that occurred also to Rahman and Weiss in a paper this year, or I guess last year. Um, and the idea is you have an information market platform in which these LLMs are managed centrally by the platform. So, like, there's a software guarantee that the LLM will, in fact, forget the information after looking at it. So the seller is incentivized. The seller can trust this. But this still doesn't solve information asymmetry fully, in the sense that, like, it solves the bias inspection paradox, but information asymmetry isn't simply about the piece of information that you are purchasing per se. It is also about, like, other meta information. I mean, not even meta information, but like any contextual information about that information. Like, the seller might have, or anyone in the world might have more information about the piece of information you are purchasing, and you are not aware of it. And this doesn't even, like, by the way, information asymmetry doesn't even necessarily need to mean that the seller knows more information than you. It can also just mean that the seller is able to find out more information, but isn't incentivized, and like, that would improve his ability to, I mean, that would enhance his ability to improve the product, but he's not incentivized to look for more information. um and, like, this information asymmetry of other relevant contextual information still isn't solved. Like, think of any other market where you have asymmetry due to information, due to sorry, inefficiency due to information asymmetry, right? You still have that information asymmetry there. Like, there's no kind of inspection that you have. Like, I mean, maybe there is, but like, sure, you can inspect inspect a product before buying it, but there can still be some kind of, your inspection isn't going to get you all the relevant information about the product. Um, so here's a totally different angle from which we can motivate the problem of information markets and information asymmetry. Let's think about RLHF. In a vague sense, the purpose of AI alignment is to make an AI do what the human wants. That is to say, if a human has a utility function u of x, RLHF makes the AI do what the human wants, superficially, in the sense that it maximizes what the human will, like, at least on a simplified level. RLHF incentivizes the AI to maximize what rating the human will give after looking at its output. This is not like there is an information asymmetry here, like, especially consider if you are purchasing you are talking to a superhuman AI that is by definition smarter than you are essentially purchasing information from it, and it has more information than you. Like, that information could be algorithmic information, like just its intelligence. There is no guarantee of efficiency there. There is no guarantee that that AI is optimized to incentivized to optimize for your true utility function. It is incentivized to optimize for what you will expect your expected utility, your estimate of your utility given what you know about it. Like, um like, whatever superficially you would judge to make sense. Or, I mean, if, in the words of scalable oversight, what this means is that, basically, you can guarantee that RLHF works for any problem that can be expressed as, for all x, h of x. There exists x, h of x, where h of x is something that a human can reliably judge. But any other type of output, any other type of question, there is no analogous guarantee. What we want to do is to the AI to maximize the human's extrapolated version with all the information that that might be relevant to the task at hand. And one way to think about it is we can think of RLHF as a scenario where the human is purchasing information from a superhuman AI, and there is information asymmetry, and maybe in order to solve this information asymmetry, the human could consult an information market where the human can then purchase more information on the original information it is deciding whether to purchase. And now there's another, so now there's like a secondary information market that has been created. And once again, there is some kind of information asymmetry here. So maybe you should consult another information market and so on and so forth. And this perspective uh, kind of hopefully clarifies what I mean when I say that simply inspection alone doesn't solve the information asymmetry problem, because like in standard RLHF, the human is looking at the information before rating it. The human is looking at the AI's outputs before rating it. Um, and like we're just trusting that the human will still give an honest rating despite not having the incentive to, like it's going to get the information regardless of what rating he gives it. But like whatever, like we trust that it is true, and that's not the problem we're trying to solve. But nonetheless, there is still information asymmetry, and that is the whole scalable oversight problem.
Sorry, I'm good.
Yeah, go on. Oh, was it a question
Oh,
there?
no question. I tripped over a cord and forgot to mute myself. Keep going,
Okay.
please.
Sure. And yeah, so the algorithm that I propose is as follows. You are a buyer, you want to purchase some information, you submit a query, which could be like it could be a literal query, a question, or it could just be some contextual information about what you're doing. Like maybe you are deciding to, well, to purchase some product on Amazon, and like the information about what you're doing, what your preferences in life are, all of that profiling info goes to a market of sellers. Those sellers who, like through some mechanism, like you can think of it as some kind of matching mechanism or a Google Ads type mechanism, um, the query is matched to certain sellers who then submit information offers, which you don't get to see. You might get to see some basic like advertisements of those information, like some public blurb, some metadata about that information, but you don't get to see the information itself. You can choose which information offers to inspect, and that subcontracts an LLM to inspect that information on your behalf, which creates this buyer one, which is now an LLM buyer. The LLM buyer can either go on the green arrow, which is the curvy arrow upwards, and it can choose a subset of those information offers to buy, or it can submit a recursive query, because once again, it is like this is a new problem, right? This is a new decision context that needs information to clarify. So it can submit a new query to the seller's market, who can then submit info offers to help the LLM buyer make its decision. And once again, that LLM buyer can choose to inspect it, which means subcontract another LLM who's like this is a separate LLM, but in the sense that what it sees will not necessarily go back to the to buyer one, and ad infinitum. And at any point, an LLM might decide, okay, I have enough information, and just decide which info offers to purchase at that point, and we can loop back all the way to the human buyer, who will then have both the info offers zero as well as any chosen subsets. Any chosen subset of info offers zero as well as any subset of the subsequent info offers that helped the LLMs make this decision for him. And you can think of this as being helpful in a wide variety of contexts, right? Like one example is as a way to improve RLHF, although the precise way to formalize that in the context of RLHF is like I'm yet to do that. But you can also think about it in the context of purchasing a product. Like there's information asymmetry between you and the seller. So you, the context about you purchasing the product, you submit that to an information market, and that information market responds with information offers, and then, but maybe those information offers are wrong. So and you get information offers 1, clarifying, like just debating what was in the information offers 0, and so on and so forth. You can see it in the context. You could apply it in the context of community notes or fact checks. Maybe you are looking at a tweet, you want to know if it's true or not. You get ads for information. You get info offers 0, which you can inspect, and then like through this debate between LLMs, you eventually get some subset of the information offers submitted. Or it could just be in the context of purchasing any kind of information that you are interested in, just for like retrieval in general. Yeah, so here's a demo of a platform I have implemented. So I have, can you see my screen? Okay, I assume you can. So I have created a user profile. So like the user basically decides what LLM he wants to make the purchases on his behalf, as well as a seller profile, which like he can create some matches to decide what kind of things to match with, and sets his API keys. Then the user can ask a question, and like in general, this could be like any kind of query. That's why we have this context pages field, which like for example, if you're looking at some news article and you want it to be fact checked or something, maybe it might make sense for some sellers to specialize on fact checking certain news websites or something like that. You set a budget. The idea behind priority high and low is that maybe in certain applications we might want users to not actively submit a query, but just like information about their context being submitted to the information market, and those would be submitted with a low priority, because like the user is probably less likely to purchase information in that case. Anyone can submit an answer, and including bots. So you can see that some bot sellers have submitted answers so far, and I'll explain in a moment how the bot sellers work. You now inspect this information, and as you can see, it has purchased the second piece of information, and you can see that so this was the balance was initially 10 and 10, now it's 7 and 7. Yeah, you can and yeah, like I can explain how a user can use it as a seller. You can create certain keywords that you want to match with, like the kind of questions you want to receive. You can also create bot sellers, which like probably the most common use of a platform like this would be for would involve bot sellers that provide some fixed piece of information that are matched to relevant questions based on keywords. So I can create a bot seller that says, I don't know, there are more penguins in New Zealand than humans, something. parameterize for it, leave LLM model and prompt blank because this is like a fixed info bot server, and then I can add some matches to it. And like the bot will automatically post this information on any question that involves those keywords, and you can probably actually see that it's probably posted. Yeah, it's posted its fixed information on this question because it has the population keyword, and we can inspect it, but it probably will not be purchased. Yeah, it was not purchased. And if you create a human matcher, then you can also find relevant questions for you in your inbox. Yeah, unfortunately, I can't show a demo of a case where there's a recursive inspection. I mean, it works in basically the same way because because the user doesn't get to actually see the recursive info offers at the end. I mean, maybe it might make sense to show recursive info offers to the user if the user has purchased that as well as all parents of those offers in the inspection ad infinitum. Otherwise, if you refuse to purchase an info offer based on a recursive info offer that helped you make that decision to refuse to purchase it, I do not think those info offers should be shown because otherwise it's possible for info to leak through those recursive info offers. Have I got time? Oh, no, I have a lot of time. I mean, I could go through some of the theory, I guess. So, like, what I'm working on right now, what I'm thinking about right now is maybe I should know this. Is how can we actually formalize what extrapolated volition means and kind of prove that this mechanism incentivizes AI systems to optimize for the humans' extrapolated volition. So, like, I have you like in a general decision problem where you want an AI to take some action X that maximizes in a general decision problem where you want to take a decision X that maximizes your utility and you want to purchase some information to help you make that decision, like you can formalize what the value of information is, and like the idea we want to express is that an AI should aim to optimize this true utility function given all relevant information. And the thing is that trying to formalize this is a bit complicated. So like one thing I can prove is that if I can differentiate between two things: the ex post value. Like these are the definitions of value of information you will find in the literature. The ex ante value uh, of some piece of information, which is in equation 4, which is the how much you would value some piece of information before having looked at it, and the ex post value of information, which is equation 2, which is how much you would value some information after you've looked at it. And I don't know if I swapped around ex ante and ex post while speaking, but equation 4 is ex ante and equation 2 is ex post. And like I can prove that with a single layer of inspection, like in the Rahman paper, AIs are incentivized to optimize for the ex post value of information, which is pretty good. But the ex post value of information itself is not what you want to maximize. You want to maximize the true value of information, but to formalize that, since the true value of information is not something that like, even the AI isn't a perfectly rational being that knows the true value of information, what you want to formalize is the idea that not only is it incentivized to maximize the expected value of u of I, but also is incentivized to seek the information that it expects will maximize the expected value of u of I ad infinitum. And that I still haven't formalized. I have not worked on that since the middle of PIBBSS. My presentation is done. I'm open for questions.
Yeah, I have a question. Yeah, can you walk a bit through like yeah, what notion of like coherent extrapolated volition you think
Sure.
this could be?
I mean, like the concept of extrapolated volition that I'm aiming for is that an an AI is incentivized to to do the actions that you would consider like that would maximize your utility given all the relevant info. And the difficulty is actually in formalizing this relevant info because like it has to do with taking the trade-offs between seeking out some piece of info and the cost of that info. um but yeah, I would differentiate it from like, so like the thing that confuses me about the coherent extrapolated volition paper itself is that I don't think the coherent and extrapolated part are necessarily related, or that the coherent part is necessary to um, uh, like one interpretation of their thesis seems to be that okay, with all the information in the world, everyone will have coherent values, which seems to be false. Like even if you think the values are the same simply because like people are distinct, they might not converge onto the same utility functions. Like one person might want all the wealth in the world for themselves and the other person might want all the wealth in the world for themselves. No amount of information will get them to converge on that. But or another interpretation could just be that okay, given all the information in the world, people can come to an agreement which like they can reliably commit to, and like the so that the total utility function between them amongst them like uh, according to some definition of property rights, is maximized. That is more reasonable, but like I think that in the most basic form, formalizing alignment itself just requires the extrapolated volition part, but it's like
Okay.
volition given all the relevant information.